Hello. So I hope you guys were able to do this example. So cosecant x is equal to -4 was given, and other information was that tangent of x is greater than 0. So we found out that the sine of x will be -1/4 because cosecant was -4, so -4/1. You can write it over here, and then when we write sine, we invert the fraction, flip the fraction or invert the fraction or take the reciprocal of the fraction. All these are same things. So it becomes -1/4. Now we draw our triangle, and using the SOHCAHTOA, place the numbers along the line. So the side, this is -1, and the hypotenuse is 4, and then we have to find the other side, the adjacent side of the angle, which I denoted by b. And so I have now b squared plus 1 square is equal to 16, which is the square of 4, and I found b square is 15, but b will be negative. Why? Because we are in the second quadrant, and x and the b is along the negative x-axis, so it's negative. So we can now find cosine of x. Then we plug in the formulas, and here are the results. You can check with your work. The next example is saying verify the addition. So again, it's about verifying, and again, if you recall, these were I'm forgetting the name of those formulas, something, anyhow. So see, these are the formulas that were given in section chapter 6, I believe, when we were looking at the fundamental identities. So this bunch of these types were given, and I told you don't have to memorize these, because you can always find out the value by applying the sum or difference formulas for sine or cosine. So these first three should be pretty simple. You should be able to do them. I mean, in the case of the second one, it doesn't matter whether you start with the right side and show the left side, or start with the left and show the right. But for the first one, you can see the left side is more complicated, so start here and apply the formula and plug in the values and the rest will be what you should be equal to the right hand side. The third formula, similarly, because the left hand side is more complicated, so start with that. And then, so I'll show you the fourth and the fifth one. So the fourth one, I again start with left hand side. So let me start here. So left hand side is equal to 1 plus, so it is sine 2x divided by sine 2x, which can be written as 1 plus 2 times sine x times cosine x, and then divided by 2 times sine x cosine x. Now note here, we cannot cancel like this. We cannot cancel this. If we were able to, we should have cancelled it over here. But that is a wrong cancellation. We cannot do that, because the 1 is being added to the top expression. So what should we do from here? Well, there is a way to think in order to get to this side. But let's say you are stuck. You say, okay, I cannot move forward. I don't know what to do next from there. So then you can go to the right hand side and work with that. So right hand side is equal to 1 plus 1/2 secant x into cosecant x. So I can always change it to sine cosine, because on the left hand side that's I see sine, so that should be the thing that should come to your mind. They convert it to sine and cosine. So we get 1 plus 1/2 times 1 over cosine x times 1 over sine x, which is equal to, so now if I take the common denominator now, first let me write it like this: 1 plus 1 over 2 times cosine x into sine x. But what is this? What is this thing? This is the sine 2x. So our expression becomes, now there are two ways to go from here. One is to keep this thing as it is, 2 cosine x sine x, and then take the common denominator, 2 sine x cosine x. So I get 2 sine x cosine x plus 1, which is the same thing that we have here. So we say left hand side and right hand side are equal. So we are done. Or we could start with the right hand side. 1 plus 1/2 which will give me 1 plus 1 over 2 sine x cosine x, we saw is sine 2x. And now take the common denominator again, which will be sine 2x. So it becomes sine 2x plus 1, which is the same as 1 plus sine 2x over sine 2x. So which is the left hand side. So we started with right hand side, we showed that it is equal to the left hand side. So we are done. Okay, now looking at the next one. This is a little bit complicated, as I mentioned earlier. So how would we start? What would be our first way of thinking? Now, like we were able to write 2x as x plus x, 3x can be written as x plus x plus x, but we don't have a formula for three terms. So what we can do is write the 3x as x plus 2x and apply the formula and then go from there. So let's see. I'm going to take the left hand side, which is cosine 3x. Going to write it as cosine of x plus 2x, which means cosine square x minus cosine square minus sine square, sorry, wrong. What is the formula? So we have to apply the double angle formula. What was the double angle formula for cosine? If we have cosine of x plus y, the formula was cosine x sine y minus cosine x cosine y minus sine x sine y. So we apply it over here, we get cosine x cosine 2x minus sine x sine 2x. Okay, I should have used a different pen color so that this doesn't get mixed. So let me use a different color. So I start with left hand side, which is cosine 3x. So we wrote it as cosine of x plus 3x. and when we apply the formula, cosine x cosine 2x minus sine x sine 2x, which is equal to, so now this is cosine x and this is cosine 2x. Well, for the second part we are sure what we will get. So for the second term over here, we get what? Sine x times 2 sine x into cosine x. Okay. For the first term, for this one, which formula for cosine 2x should I use? That's the question. Okay, but the thing is, just go ahead, write any formula that you remember, and then we can always see what manipulation we need. But anyhow, so let's do it. So cosine of x times cosine square x minus sine square x. But if you notice here, and in the middle is a negative term, if you notice here, we have a, what we have to show is cosine x times 1 minus 4 sine square x. So we have no cosine square x term, so it would be better if we use the other formula for the cosine, which has no cosine square x. So cosine x times 1 minus 2 sine square x. The only difference this will do is it will take less time and less work to do it, to show it. So distribute, so I get cosine x minus 2 times cosine x into sine square x, and if I look at this term, this is minus 2 cosine x sine square x. Now we combine the last two terms, so we get cosine of x minus 4 times cosine of x times sine square x. We can factor out the cosine x, get 1 minus 4 sine square x. So we have proved this, that the left hand side is the same as the right hand side. So the identity has been proved. Okay, so now we will move on to next section, which is 7.4.